13.3 about the partial derivatives. Okay, so maybe you studied the partial derivative in calculus 101, but this definition of partial derivative may be little changed because I'm not sure that how you study the partial derivatives in 101. Here we have the functions of more than two variables. So we need to find the partial derivative with respect to x, with respect to y. And if the function is in 3 dimension, okay, I have 3 parameters, x, y, and z. So you can find the partial derivative along the x-axis, along the y, and along the z-axis. So this is about the 13.3 partial derivatives. So before going to start how we can find the partial derivative, there is a definition of partial derivatives. So how we can define the partial derivatives. Okay, so what is the definition of the partial derivatives? That if you have any function, how you can define in terms of the logical meaning of this one, that if you have any function, z is any function in terms of x and y. Okay, here we take a function of two variables, x and y, and x naught and y naught is the point, in the domain of the function, in the domain of function f. Then the partial derivative of the function f with respect to x at x naught, y naught, that is also, you can represent that also called the partial derivative, also called the partial derivative of z with respect to x at point x naught, y naught. Okay, either you can write the function f or write the z, because z is a function of x and y, so you can choose either z or either f. So it's a derivative, it's the derivative at x naught of the function that results when y is equal to y naught is held fixed. Okay, and x is allowed to vary, so that means that you have to choose the y function as a constant because it is fixed, and x is varying variable, so x is the parameter. Okay, so this is the partial derivative, this is partial derivative this partial derivative or this partial derivative is denoted by you can also denote this one as like this one, f of x at point x naught, y naught, and also you can have the notation of the partial derivative like this one, that f of x, x naught, y naught, this is also equal to d by dx of the function at point x and y naught you choose, and here you will write x is equal to x naught. This is also equal to the limit delta x approaches to 0, f of x naught plus delta x into y naught minus f of x naught y naught divided by delta x. Okay, so this is the definition of the partial derivatives. Okay, now this is the definition. So this is the definition of partial derivative with respect to x. If you want to find the partial derivative with respect to y, okay, with respect to y, so this is the point where you have to fix. Here x naught is the varying function and y naught is fixed. So the alternative for the y naught function. Okay, so I will give you one example so it will be very clear that how you do the partial derivatives. Maybe you already know. For example, there is a example that find partial derivative of x 1 and 3 and y 1 and 3 for the function xy, which is equal to 2x power 3 y square plus 2y plus 4x. Okay, now you have to find the partial derivative with respect to x and with respect to y. Okay, so how you can do the partial derivative? Sorry for the background sound. Okay, there is a call from my colleague, so he is attending the call. Okay, so since there is a partial derivative you have to find for the partial derivative of x at point 3. Okay, so this is equal to what? D by dx of the partial derivative of the function at point 3, and you have to put x is equal to 1 here. Okay, so what is the definition? Basically that when you want to find the partial derivative with respect to x, you have to choose the y function fixed. Okay, and we have to find the partial derivative of 1 and 3, so we have to fix the y, and the fixed value of y is 3, so I have to find the function value at x and 3. Okay, so this is equal to what? D by dx of finding the point at the 3, so this will become 2 into x power 3 and y value is fixed, that is 3 square, plus 2 into 3 plus 4x, plus 4 square, plus 2 into 3 plus 4x, plus 4 square, plus 2 into 3 plus 4x, plus 4 square, 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 plus and x is equal to 1. So what will be the function becomes 3 square is 9, 9 multiplied by 2 is 18, x power 3 plus 6 plus 4x, and x is equal to 1. Okay. What is the derivative of 18 x power 3? What is the derivative of 18 x power 3? 54 x power 2. What is the derivative of 6? 0. What is the derivative of 4x? 4. Yeah, 4. And now you have to put x is equal to 1. When you put x is equal to 1, that implies partial derivative of 1 and 3, which is equal to 54. 1 square plus 4, that is equal to 54 plus 4 is equal to 58. Okay, so this is how you do the partial derivative at a fixed point. This is the method 1. This is the method 1. I will explain the second method, which you find easy. You can attempt that in the final exam. Okay, the second method for finding the partial derivative for with respect to x is this one. That function is given, f of xy is given, which is equal to 2x power 3 y square plus 2y plus 4x. Okay, now you have to do the partial derivative with respect to x. So when you are doing the partial derivative with respect to x, you choose function y as a constant, variable y as a constant. So partial by partial x of this function, 2x power 3 y square plus 2y plus 4x. Okay, now for the first term, 2 is a constant, y square is a constant. So you take these terms outside. Now what left? X power 3 left. So what is the derivative of x power 3? Derivative of x power 3? 13.3. 13.3 Abdullah. Okay. So what is the derivative of x power 3? That is 3x power 2. Okay. Now plus 2y is a constant. So what is the derivative of a constant? What is the derivative of a constant? 0. 0. Because with respect to x, y is a constant. Okay, when you do with respect to y, then the derivative is 2. With respect to x, the derivative is 0. Okay, so what is the derivative of 4x? What is the derivative of 4x? 4. So right here 4. Now simplify. F of x, xy is equal to what? 6 x square y square plus 4. Substitute the value of the point, which is 1 and 3. 6 into 1 square into 3 square plus 4, which is equal to 6 multiplied by 9 plus 4 is equal to 54 plus 4 is equal to 58. The same answer. Okay, if you find this one easy, you can use this method. If you find the previous one is easy, you can use that method. Okay, this is for the partial derivative with respect to x. Similarly, we can find the partial derivative with respect to y. See, the function is given. This is the function. Okay, now with the same method 1 and method 2, I will explain. Now you have to find the partial derivative with respect to y. So when you are doing the partial derivative with respect to y, you choose x fix. So that is 1y, which is equal to d by dy of the function at point 1 and y, and then you have to find y naught is equal to 3. Okay, so this becomes d by dy, and substitute the value of x in this variable, in this function. That becomes 2 into 1 power 3 y square plus 2 into y plus 4 into 1, and here y naught is equal to 3. D by dy is equal to 2y square plus 2y plus 4, and y naught is equal to 3. What is the derivative of 2y square? What is the derivative of 2y square with respect to y? That becomes 4y. What is the derivative of 2y? That is 2. What is the derivative of 4? 0. Okay, now you have to substitute y naught is equal to 3. So f of y at point 1 and 3, which is equal to 4 into 3 plus 2, which is equal to 12 plus 2 is equal to 14. Okay, this is for the method 1. Similarly, you can find the same partial derivative with respect to the second method. Okay, so what is the function f of xy is equal to 2x power 3 y square plus 2y plus 4x. Okay, find the partial derivative with respect to y. That means partial by partial y of this function, that is 2x power 3 y square plus 2y plus 4x. Now you have to choose the x function as a constant. So this is a constant you can take outside. So what is the derivative of y square? The derivative of y square is 2y. Now what is the derivative of 2y? That is 2. What is the derivative of 4x? Anybody can tell me what is the derivative of 4x? Ahmad?
0.
0. 0, 0, 0. Yeah. So this is 0. So that becomes 4x power 3 y plus 2. Okay. Now substitute the value. This value is 1 and 3. When I put 1 and 3, that becomes 12 plus 2 is equal to 14. Same answer. Okay. So this is the second method. You can use any method in the exam which you find easy. Okay, so this is the basic definition, or you can say the basic rule to find the partial derivatives of any function it is given to you. Okay, now there are different types of notations of the partial derivatives. What are the notations? Partial derivative notations. Okay, so what are the basic notations we use to find the partial derivatives? Like for example, if I say, if you have any function z of x and y, then the partial derivative f of x and f of y are also denoted by like this one. You can also write partial f by partial x. You can also write partial f by partial y. You can also write partial z by partial x. You can also write partial z by partial y. Okay, because z is a function. Z is also a function. So you can choose any of the notation for expressing the partial derivatives. Okay, now if you have this type of function, that example, little complicated one. Okay, so you have to find partial z by partial x and partial z by partial y if there is a function z which is equal to x power 4 sine of x y power 3. Now you have to find the partial derivative with respect to x and with respect to y of this function. Okay, so how we can find partial z over partial x of this function x power 4 sine of x y power 3. Okay, now partial derivative of this one, you have two functions multiplying with each other. So how we can do the partial derivative? You have to apply the product rule. You remember the product rule? First function same and the partial, this is x, okay, and the partial derivative of the second function, okay, plus second function and partial derivative of the first function. Now x power 4, what is the what is the derivative of sine? What is the derivative of this one where y is a constant? Okay, where y is a constant, what is the derivative of sine?
Cosine.
Yeah, x y power 3 and then
Uh,
partial derivative of x y power 3, right?
yes.
Okay, now sine of x y power 3, what is the partial derivative of x power 4? 4 x
4x,
power,
y3.
yeah, 4x power 3. Now x power 4, yes, cosine x y power 3, what is the partial derivative of x y power 3 with respect to x? Anybody can tell me?
Y. 3y.
Y, no, with respect to x, think again. 3x square, no, I told you when you are doing the partial derivative with respect to x, y is a constant. So y power 3 is a constant. What is the derivative of x?
1.
1. So no need to write. That's it. Plus this you can write 4x power 3 sine of x y power 3. So this is the derivative. Got it? Understand? Now with respect to y, z is given, which is equal to x power 4 sine of x y power 3. Now what is the partial derivative of z with respect to y? Partial by partial y of x power 4 sine of x y power 3. Okay, now x power 4 is a constant, so you can take the constant outside, and partial derivative of y of sine of x y power 3. What is the derivative of sine? The derivative of sine is cosine x y power 3, and now you have to take the partial derivative of x y power 3. Now who will tell me the partial derivative of this one with respect to y? X power 4 cosine x y power 3. What is the derivative of x y power 3 with respect to y?
3x
3x, okay, 3x, 3x y power 2. Okay, so this is the partial. You can simplify also like this one, 3x power 5 y square cosine of x y power 3. Okay, so this is the partial derivative of the function. Now there is a definition of partial derivatives as a slope. There is a notation that how you can do the partial derivatives as slopes. Okay, so what is the meaning of this one? That if you have any function and whose derivative you can find with respect to x, this is the slope of the surface z is equal to f of xy in the x direction. Okay, this the partial derivative with respect to x is the slope along the x direction. If you do the partial derivative with respect to y, that is the slope of the surface z is equal to f of xy in the y direction. Okay, so don't confuse in the exam. If I ask you to find the slope of the function in the y direction or x direction, you have to simply find the partial derivative with respect to x or with respect to y. Okay, so if it is given that you have to find along the x direction, so it means you have to do the partial derivative with respect to x. If I ask you to find the slope along the y direction, okay, y direction, that means you have to find the partial derivative along the y-axis. Okay, so I will give you one question so that you should know that what will be the statement maybe appear in the exam. Okay, so for example, there is a question that let you have any function f of xy which is equal to x square y plus 5y power 3, and you have to find the slope of the surface z is equal to f of xy in the x direction at the point 1 and minus 2. So in the previous definition, that if you have a slope, if you have to find the slope of the surface in the x direction, that means you have to find the partial derivative with respect to x. Okay, so the partial derivative with respect to x of any function, the function is given, so it means partial by partial x of this function x square y plus 5y power 3. Okay, so what is the partial derivative of x square y? Anybody can tell me what is the partial derivative of x square y? Anybody? 2xy. Very good. 2xy plus what is the partial derivative of 5y power 3? 5y power 3. No, with respect, Abdullah or Abdullah, I don't know. It's Hamza. Okay, I will say Hamza. Hamza, this is the partial derivative with respect to x. There is any x in this function, in this term, 5y power 3. So the derivative is 0. Okay, so the derivative is 0. Now you have to find the surface slope at the point this one. So the derivative along 1 and minus 2 will become 2 into 1 into minus 2, that is equal to minus 4. So the slope of the surface z is equal to f of x y in x direction at minus 1 and 2 is minus 4. So this is the slope. Okay, if I ask you to find the slope along the y direction, so what you have to do, you have to just simplify the same function and take the partial derivative with respect to y. So we will do this one also. B part, what is the B part? That find the slope of the surface z is equal to f of xy, okay, in the y direction at the point plus 1 and minus 2. Okay, the same point and the same function. The function is given f of xy is equal to x square y plus 5y power 3. Now the direction is what? The direction is what? Y direction? Yes. So you have to do the partial derivative with respect to y. So f of y of xy, that is equal to what? Partial by partial y of this function x square y plus 5y power 3. What is the partial derivative of x y power x square y? With respect to y, Hamad. With respect to Hawaii, y, Ibrahim. With respect to y. No, Ibrahim. C. C, C, C. Yeah. X square y. So x square is the constant. You can take constant. Only left what? Y. What is the derivative of y? 1. So no need to write. Okay. Now, what is the derivative of 5y power 3? 15 y square. Now you have to use this point, the partial derivative at point 1 and minus 2, which is equal to what? X value is 1 and y value is minus 2. That is equal to 1 plus 15 multiplied by 4, that is 1 plus 60, which is equal to 61. So the slope along y direction is 61. So is this clear? Okay, good. So this is how you can find the partial derivatives of any function, or it is given that you have to find the partial derivative or it is given that you have to find the slope of the function. So they have the same meaning, and so don't confuse. Okay, I say again, then don't say that we don't know how to find the slope of a surface in terms of functions. Okay, so this is the partial derivative. Simply, there is no definition about the slope. Slope is basically the derivative. Okay, and when you talk about the derivative in terms of fixed x and y, that means you are talking about the slope of that curve. Okay, f is a surface, and any surface have some slopes, either decreasing, increasing, or x-axis along x-axis or y-axis. So whenever the surface is given, you can easily find the slope of that surface, either in the x direction, either in the y direction. If it is x and y, if it is x, y, and z, you can find along the x direction, y direction, and z direction. Okay, so now I will give you 10 minutes break, and then we will discuss